Elon Musk is looking to optimize his reusable, cost-effective SpaceX rockets in a bid to enable us to travel deep into space and even beyond at a faster rate. The tech billionaire has a goal to colonize Mars by 2050, but is confronted with two significant physics-related problems: distance and speed. Due to the enormous distance and the speed limitations of the existing spacecraft, it takes several months to travel to the Red Planet. Knowing Musk for who he is, he would certainly prefer a quicker alternative. Basically, that would require a redesign of the existing spacecraft, making them more efficient and transporting humans and cargo to space within a shorter period of time. At the moment, there are quite a number of options that could offer us this possibility, but powering rockets with nuclear technologies seems like the most viable solution of them all. Space exploration technologies have improved over the years. I mean, who would have thought it was possible to explore and perform experiments on different planets with robots? We literally went from struggling to cross the Kármán line to sending probes beyond our solar system. While these achievements are inviolable, scientists feel there's a need for humans to move faster within space. But why is that? Space is a vast area with hundreds of millions and billions of miles between every 2 points. Even the sun that looks pretty close to us is 152 million kilometers from the Earth. The moon is much closer, but even that is almost 400,000 kilometers away. On average, you'll need 3 days to travel to the moon. Considering the distance, the timing is not exactly slow. But we can do better. Musk shares this sentiment as well. In an interview in 2019, the talented entrepreneur claimed that nuclear thermal rockets would be a great area of research for NASA. According to Musk, powering spacecraft with nuclear energy would automatically translate into faster travel times around space. And that's where the possibility of a nuclear-powered space rocket becomes even more exciting. To begin with, a nuclear-powered rocket would produce several times more thrust than the existing spacecraft. For perspective, the Saturn V rocket that transported Neil Armstrong and Buzz Aldrin to the moon had a specific impulse of 421 seconds in its second-stage boosters, while a typical nuclear-powered rocket is expected to deliver a specific impulse of 900 seconds based on the estimation by the European Space Agency. And depending on the way it is designed, nuclear-powered rockets can be optimized to deliver 100,000 seconds of specific impulse. In fact, the concept has been discussed sparingly within NASA since the 90s. The House Appropriations Committee recently allocated $125 million to explore nuclear thermal propulsion. The US Congress also approved $100 million in funding for a similar cause. And Russia's Roscosmos has been actively exploring the development of a nuclear-powered space cruiser that can travel to Mars. That's because nuclear-powered rockets are viewed as an upgrade that could revolutionize how we travel in space. And aside from being super fast, such rockets could also reduce the cost of space travel. Nuclear thermal propulsion (NTP) systems offer the greatest versatility for near-term deep space missions such as NASA's planned Mars and near-Earth asteroid missions. Dan Cutler, an assistant professor of nuclear and radiological engineering at the Georgia Institute of Technology, told Unveils at the time. Due to their superior energy density, these systems have nearly twice the efficiency of the best chemical engines paired with comparable thrust levels. If this idea eventually becomes a reality, there will be many private and government-owned entities looking to take advantage of it. NASA intends to return to the moon in 2024, and that could be the perfect test project for a nuclear-powered rocket. The United States Department of Defense could also use such spacecraft to dispatch soldiers and weapons across the world within minutes. Private astronomers and prospective space travelers are smacking their lips at the possibility of achieving their lifelong dream at a discounted price. Potentially, the main objective of this interesting invention would be to transport humans and cargo to Mars as part of Elon Musk's ambition to colonize the Red Planet. But is it realistic? Mars is far away from our Earth, and even more, the distance between both is constantly changing due to their orbit around the Sun. The distance between them ranges from as low as 54.6 million kilometers to as much as 401 million kilometers. However, scientists have found the best energy-efficient orbit to travel to Mars. It's called the Earth-Mars launch and occurs only once in 26 months. With that sorted, attention quickly moved to the requirements that would be needed to create a self-sustained city on the Red Planet. And there's no better person to provide us with this information than Musk himself. The Tesla CEO believes that to colonize Mars, we'll need to relocate 1 million people and around 1 million tons of cargo to the planet. This might sound like a lot, but to colonize Mars, we'll need to build new infrastructures like houses, roads, power and oxygen generating plants, and telecommunication systems, among other things. Based on the capacity of Starship 1.0, The tech billionaire estimates that the total cost of creating self-sustainable colonization on Mars is $10 trillion. That's about 10.64% of the world's economy. And if we're being honest, that's way more than Elon Musk can afford. But thankfully, experts believe that the new Starship 2.0 that SpaceX is developing can execute the project for a much lesser price. Now imagine how much more we'll be able to save if we decide to power the Starship 2.0 with nuclear energy. Sounds fascinating, right? Well, it's only an ambitious dream for now, but it could introduce us to a new era of space travel, where humans would be able to literally journey between planets and interplanetary bodies within minutes. With that said, let's take a look at the features of the Starship 2.0 and how it compares with its older sibling. As expected, the Starship 2.0 will have more capacity and carry more features than its predecessor. To begin with, reports suggest that it would be 4 to 8 times bigger than the first generation model, which means it will accommodate more people and cargo. Although nothing official has been said about the height, we expect the redesigned version of the Starship will be taller. And just for reference, the Starship 1.0 is 400 feet tall when attached to the Super Heavy rocket booster. That's taller than the famous Statue of Liberty and the Saturn V rocket that transported NASA astronauts to the moon in December 1968. The Starship 1.0 is equipped with the Raptor engine, which delivers 180 metric tons of thrust. Meanwhile, the upgraded Starship 2.0 will get an optimized Raptor engine with 230 metric tons or 500,000 pounds of thrust. This proposed upgrade could as well be the perfect opportunity to conduct a trial, who knows? The diameter of the Starship 2.0 is estimated to be 30 feet. For perspective, the average fuselage diameter of a passenger plane is only 20 feet. The old Starship could carry 100 tons of cargo at a time. The new version could be able to lift up to 1,000 tons at a go. That means, based on Musk's calculation, we can transport the cargo needed to colonize in 100 trips, and it could be less if scientists decide to power it with nuclear energy. One industry that would also benefit from this innovation is space tourism. Imagine a world where you could travel to the moon or Mars for vacation. Well, you had better start saving, because it could be a reality soon. A nuclear-powered spacecraft would also help Elon Musk loft more Starlink satellites to orbit, because why not? SpaceX plans to create a mega constellation of 42,000 high-tech satellites in orbit, and they can always make do with a faster spaceflight. However, of all the potential customers of Starship 2.0, experts believe that government space agencies will be one of the biggest beneficiaries. Every year, NASA and the ESA spend hundreds of millions of dollars building and launching rockets, probes, and several space missions. On average, launching a single satellite into space would cost anywhere between $50 to $400 million. If Elon Musk's goal to build nuclear-powered rockets is achieved, NASA could be launching satellites for less than $1 million. The same would definitely apply to space shuttle missions, which on average should cost $500 million. All of these ideas and numbers sound too good to be true, but the reality is we might not be far away from witnessing it. Be sure to check out this video over here.